Okay, good. Yeah, should be this one, is it? Yes, this one. Okay, trigo notes. Let me just update the date first in case I lose the file. What's the date today? 221014. Okay, so right. Maybe I should edit this. Compound angle is also known as addition formula, aka addition formula. If you want to Google online, like for extra explanations, addition formula. That's what you should look for. Compound angle formula means the same thing. Also, I should have done the following. I should have categorized these three functions, these identities that is required in the AMAX syllabus into the following categories. Let me just categorize them. The first three is called Pythagorean. You already know this, right? Yeah. Let me write it neatly for you. And the next tree is addition formula. Okay. The next tree is addition formula or compound angle. Addition or compound angle formula. And then after that, these two, what is it? It's simply replacing the B with an A, right? So it becomes 2A and you get what's known as the double angle. Right? Let me see if I can make this a bit nicer. Okay, yes. Oh. Double angle. What is so special about double angle is for sine, it becomes a product of sine and cosine. Do you see that? So from product, it becomes a single term. And sine has how many identities for double angle? Only one. Only one. Whereas for cosine, how many versions? Three versions. Very good. So what else do you notice? If you focus on the first version, you get cosine square minus sine square. Doesn't that remind you of a certain algebra identity?
Pythagorean.
That's actually correct. But I was trying to lead you towards another direction, which is relevant to the question 8. X square minus y square. Can you factorize this?
Yeah.
Which is?
X plus y, x minus y.
Exactly. So that means that you can also apply it over here for cosine square minus sine square. Just replace the x with cosine A, replace the y with sine A. So that's the first version, how you could apply it. You could split it up, and that's what we're going to do later. However, let's just, since we're talking about double angle, let's just continue a bit more. So here, 2 cosine square A minus 1 versus cosine 2A. What's the relationship here? What's so special about this? Can you see any special patterns? Compare with the previous one, cosine square A minus sine square A. Now it changed to 2 cosine square A minus 1. That's because you substitute the sine square. But more importantly, what are you left? What are you left with?
What are you left with? What are you?
Like it's just 2 cosine square A, but what's more important? What's a general pattern you can see? Is it too big a question?
Yeah.
Too big. Okay, then how about if you compare with 1 minus 2 sine square? Cosine 2A becomes 1 minus 2 sine square. What's so special about these two? 2 cos square A minus 1 versus 1 minus 2 sine square A. Okay, maybe you cannot see the pattern I'm trying to bring up. Basically, the pattern I'm trying to bring up here is that here, previously got cos square A minus sine square A is a mixture of cosine and sine. Whereas over here, it's purely in terms of cosine. Do you see that?
Oh, okay.
Only cosine. Whereas the other guy, it's only in terms of sine. So that could be useful in your problem solving when you are trying to prove identities. Like you see the final result on the RHS. Oh, everything is in terms of cosine, don't have sine. And then you got double angle. So that naturally means that you should pick this guy instead of that guy because you want more cosines. Does it make sense? Right? So that's how you can interpret the double angle. What else? Anything else? Something very important about this one. You need to know it for integration in the future. What is so special? Previously, we got square, 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 square. Here, then suddenly don't have square. Here also don't have square. And then suddenly the square comes back in. But over here for the cosine, is there a square?
No.
Don't have square. Here, there 2 cos square A, have square. So let me show you, this one is extra already. That's not really in AMAX syllabus, but it will be required if you are doing engineering max. Cosine of 2A is equals to 2 cos square A minus 1. Can you make cosine square A the subject?
Make cosine square A the subject.
Don't square root, just
bring the 1 over.
So you can take cosine 2A, then let me see, how do I write this in a way that looks nice. Let me think a bit. I'll put the 1 at the left side. Okay, 1 plus cosine 2A, and then I divide by 2. Is that true?
Yeah.
Yes, okay. The minus 1 you bring over, so it becomes 1 plus cosine 2A. Then you have a 2 cos square A, so divide over. So what is so special about this is that the power 2 drops down to power 1. Do you see that? That's very useful. That's very, very useful. This is known as the power reduction formula. Extension already. This one extra, not in AMAX. Power reduction formula, but occasionally you may have to use it in some very difficult prelim paper question where they test you on reducing the power. You need to know this pattern. Cosine square A can be replaced with 1 plus cosine 2A over 2. The power will drop by 1. However, the angle, the argument inside will get doubled. Okay, likewise for the sine square, you can do the same thing, right? Take a look. Cosine 2A equals to 1 minus 2 sine square A. So if I try to make sine square A the subject, what do I get?
Sine square A the subject. You get
1
plus
minus
1 minus 1 minus cosine 2A over 2.
Exactly. Can you see the pattern? There's a bit of symmetry here. Plus become minus. In the future, you'll see this, but basically it's related to what you're learning now. You just make sine square the subject, you make cosine square the subject. Okay, so you also can have a reduction of the power. Sine square suddenly drop to a cosine. Okay, I know it's not relevant to sine, it suddenly become cosine, but the power drops by 1, which is very good. When the power drops by 1, it's a very, very wonderful thing. It's very, very useful. I need to bring that to your attention. Okay. And if you cannot understand, never mind, just throw away. Not important for now. Okay, power reduction. So power 2 become power 1, power 2 become power 1. Okay, that is on double angle identity. And then, I forgot to open the bracket all the way. That's also for the tangent. Just replace the B with A. Okay, so there are only these 3 identities to use. You just have to keep on playing around with these 3 groups of identities. Okay, let me just copy this over and then I will continue talking. Yeah, so let's just. Okay, I think I better make it line paper. Yeah, so let's just continue where we left off. You have a cosine A over 2 minus sine A over 2. Oops. Right? And you're trying to eventually prove that, okay, LHS equals to ... You're trying to eventually show that it will be equal to the RH. Sorry, you're starting from the LHS. You want to show that eventually it will become a secant A minus tangent A. Okay. Objective clear? You started with right hand side. Sorry. Right, that's what you did so far, right? Question 8. Then now, the trick here is that if you see cosine A over 2, sine A over 2, you see angle A, you realize you need to use double angle identity. So you either use sine 2A or you use cosine 2A. So there are 4 formulas for you to use, right? But here clearly, okay, I'm not sure if it's clear or not, but maybe it can still work if you use sine 2a, but one possible route that you can take is to realize that this fella here seems to work. Cosine square a minus sine square a. What happens if you factorize it? Cosine square a minus sine square a, you end up with, let's just do it on the side. Cosine a plus sine a times cosine a minus a. Exactly, good. But then, there is a problem here. You see, here you got a over 2. Here you have a sum of cosine and sine, but it's a over 2. Here you have a sum of cosine and sine as well, but it's a instead of a over 2. But no need to worry, right? This a here, a here, a here, a here, a here, a here is just any angle. You could have always changed it to theta, right? Okay, maybe like this, theta, all the way, which means that in our formula list, instead of cosine 2a, it will be cosine 2 theta. Then you can simply replace the theta with a over 2, which means that 2 theta will be replaced with a. This symbol here means replaced with. Theta is the beginning symbol. You're going to replace it with a over 2. Okay. Then after replacing it, what happens? Cosine 2 theta becomes cosine a, which is cosine square of theta becomes a over 2, minus sine square of theta, which is a over 2, which is cosine a over 2 plus sine a over 2. I'm just replacing the theta with a over 2. Can I don't need to say so much. Okay, is it clear? Just substitute. Clear so far?
Okay.
Can so because we see that it will become cosine a when you take the sum multiplied by the difference, also known as the conjugate. That's why exactly at the second fraction here, that's why I decide to multiply top and bottom by cos a over 2 minus sine a over 2. I want the denominator, so I can multiply with the other denominator to get the cosine a. That's my objective. So that I can link it to secant a and tangent a. But on the numerator, no choice, I have to tag along because that's the only way that we can manipulate the fraction. We can only multiply by a weird format of 1. I'll call this the weird format of 1. Weird form of 1. Right, you're just multiplying by 1. It's just that the top and bottom looks a bit different. They will still cancel away, become a 1, but of course you don't try to cancel it. You multiply the denominators, get cosine a, then you multiply the numerators. So here you have to think about the numerator. Same expression, what a coincidence. Okay, what a coincidence. That means that it's really just cosine a over 2 minus sine a over 2, bracket, square. Right? Can now? Okay. Then we can expand cosine square minus 2 times cosine a over 2 times sine a over 2 plus sine square a over 2.
So 1 minus 2 cosine a over 2 sine a over 2.
Sorry, say again.
It become 1 minus 2 cosine a over 2 sine a over 2.
Correct. Very good. Yes, because cos square plus sine square is 1. As long as the angle is the same. So now it's not always angle A, sometimes A over 2 also can. So maybe I'll just write it like this. Wow, looks bad. Let me try again. Let me shrink this down a bit. What was I saying? Yes, the cosine square and the sine square add together becomes a 1, even though the angle is no longer A. Right? Here, even though it says A and A, you can always replace the A with A over 2. So I'll just circle and circle and circle. Okay, but wait, take a look. 2 times the product of cosine and sine and the angles are the same.
2 times the product of sine. Use this.
Exactly. So now what can you replace it with? 1 minus?
Sine A.
Not 2A, man. The formula say 2A. Do you just read it literally as 2A?
No, because it's A over 2.
Exactly. You double. It's a double relationship. Double of A over 2 is just a single A. Can?
Okay. I
Then
almost
now
fell
do you
for
see how it's secant A and tangent A?
Yeah, okay. 1 over cosine A, which is secant,
Got it.
then minus tangent A.
Exactly. Good.
Wow.
Okay. Not easy, this one, not easy.
But I feel like, okay, yeah.
Okay, I mean, actually, I think it's quite easy for you. You can do it
No,
quite
I
well.
feel like I only can do it because you are like guiding.
Yeah, true, because I already have the solution at the end of the day. That's why it's easy.
Yeah.
But the trick here is just look at the angle, okay? Follow the 13 tips. Okay, A over 2 here, you want angle A, double angle. Then you must guess and check, no choice. These three options. So do you think there's another way to do it? Could there possibly be another way instead of multiplying by this weird form of 1?
Another
I
way.
think there is. I think there is. Here is another way that I suggested. But a point to take note here is usually there is more than 1, more than 2, more than 3 options to do trigo identities. It's not restricted to one fixed way. So even though I suggest you multiplying this fraction, feel free to come up with other ways to solve the question. Okay. Feel free to come up with other ways. Okay, if you are not sure, then you can let me verify. Yeah. Then another way that I suggested is, how about if we multiply top and bottom by cosine A over 2? Yeah, we multiply by another copy of cosine A over 2, cosine A over 2. Why do I want that? Because I don't know, maybe it could work. Because I realized that cosine power 1, sine power 1, not many things we can do. Not many identities we can use. You see, most of the identities involving cosine power 1, they need to be multiplied with something else. You see that? Cosine power 1 multiplied by something else, or sine power 1 multiplied by something else. So that's why I think, hey, how about if we just multiply by a cosine? Let's try that instead. Let's see if it works. Okay, just to explore. The blah 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 eventually becomes cosine A over 2 minus sine A over 2. Let me just copy it down first. How about if we multiply top and bottom by, here's a crazy thought. What if we multiply by another copy of cosine A over 2 times cosine A over 2? I mean, at the top and bottom. So it becomes cosine square A over 2 minus sine A over 2 times what's that, cosine A over 2.
This looks like the sine 2A one.
Yes, correct. But then something is missing. Remember, the formula is 2 sine A cos A is the same as cosine 2A. Sorry, sine 2A. What am I saying? Okay.
2 is missing.
So it's missing a coefficient of 2. But we can always
times 2
times half. Right?
Okay.
So here's a clever trick. What if we just introduce a times 2 and a times half? So we force the 2 out and then we times the half. Okay, I'll just put a times. Okay, then after that we can factorize. So this, I mean not factorize, use an identity. So that becomes what? That becomes cosine square A over 2 minus half of sine 2 times A over 2. That's just an A. Likewise for the bottom. Is that useful?
I don't know.
See. Okay, that might be quite useless. Doesn't lead to anything because we still have cosine square A over 2. Oh, that's not good. Still got cosine square A over 2, which is not good. So that's when you think at the original function, there's no square. I mean, at the eventual result we want to reach, there is no square, but here got square. So wouldn't it be nice if we can reduce the power?
Yes. Yeah, okay. Power reduction. Yeah, okay.
Yes, reduce the power. Let me just, I'll just copy and paste it. So we don't need to waste time. Okay, so cosine square A equals 1 plus cosine 2A over 2, right? Do you want to derive on your own? Again, as an exercise?
Okay.
Yeah, go. Maybe I show you the formula. Like, yeah. Should I copy it down? Then you got more space. How to derive that power reduction formula? Oh, fancy name. Reduce the power by 1. Cosine squared.
Wait.
Yep, correct. 1 plus and
Oh.
cosine. Doesn't matter. Order. 1 plus cosine plus 1, same thing. Then finally divide by 2, right? And while you're at it, how about you change the cosine square A to cosine square A over 2 instead? Then everything
And
divide.
it's A.
Yeah, exactly. Yeah, so now we can replace. Okay, I'll just copy down. Hey, don't erase it. Let me just copy down what you wrote. Oh, yeah. Replace cosine A plus 1 divided by 2. Cosine A plus 1 divided by 2. Minus half sine A plus half sine A. This is a more complicated way of doing things, but I think it still works. Then here you realize that half sine A, isn't that just sine A over 2? Yes, so we can rewrite it as a fraction. Maybe something like sine A.
Times 2 top and bottom.
Yes, exactly. Okay, let me just write it neatly first. Yep. Okay, and also it's a fraction minus a fraction, fraction plus a fraction. Denominator is the same. So maybe we combine them. Actually, it's the same thing. Okay, you get it already. Never mind. Just do it. So bracket, times 2 at the top, times 2 at the bottom. You're essentially multiplying by 1. Then you end up with cosine A plus 1 minus sine A all over cosine A plus 1 plus sine A. Is that useful? Not really, yeah. Because we need to show secant A minus tangent A. I might have led you down a wrong rabbit hole.
Cosine A plus 1 and times conjugate. I don't know.
Times the conjugate. Sure, why not?
Cosine A.
Sorry. Yeah.
Times conjugate.
Yeah. Cosine A plus 1. Minus, right? You want conjugate of the denominator or numerator? Or plus?
Minus, I guess. I don't know.
Okay, sure. Then if you stick to minus, the top and bottom must be the same because you are multiplying by a weird format of 1. So top and bottom must be the same. Denominator becomes what? Rather complicated. This square minus that square. Okay. Let's just deal with the denominator all the way. So if you expand this out, you end up with cosine square A plus 2 times cosine A times 1 plus 1 square, which is just 1, minus sine square. Wow, that's very confusing because you're introducing a cosine square minus sine square, which is just cosine 2A, but you don't want 2A because you're trying to work your way towards secant A plus tangent A. At this stage, let's say that you are stuck. What is the procedure you should do? You are working from the left-hand side towards right-hand side and you got stuck. What should you do?
Make right-hand side. I don't know. Make it complicated. I don't know.
Work from the right-hand side. Okay. You pause.
Okay.
You pause and then you go start from the right hand side, you start working your way towards the left. It's like let's say that you are, imagine this is a tunnel and there are some people stuck inside. You can approach them, you can mine, and then and rescue them from the left, but you can also rescue from the right side, right? Who says you must really just go one direction? Later, if you get stuck by a boulder, then you keep on drilling. By the time you finish drilling, the people inside no more oxygen, they pass away. Cannot, right? So you should try to be smart and adaptable. Approach from the other direction as well, right? Okay, whatever. Just approach from the right side. Okay, so secant A, I think straight away it's clear it's 1 over cosine. Tangent is also sine over cosine, right? Then you see fraction plus fraction, what do you do?
Fraction plus fraction.
When you
1 plus
add
sine.
fraction, yeah, you make the denominator the same first, but coincidentally it's the same. So you just 1 plus sine A, or divided by cosine A. So you realize that the denominator should only have a single cosine A, but our expression here has cosine A plus 1 plus sine A. Wow, that's no good. Right or not? That's not very good.
Yeah.
So, wow, I think maybe the method I have chosen is not so smart. Yeah, I don't think it's such a smart idea to continue. Because you see, we made it worse. Previously, we had what? We had two terms here. We want to boil it back down into a single cosine A, right? And the correct way to do it, one correct way to do it was to multiply by the conjugate so that we can simplify using a special identity over here into just a single term, right? So from two terms, previously was cosine A over 2 plus sine A over 2 in the denominator, two terms. Now it becomes one term. So that way was good in that sense. It reduced the number of terms to what is required on the right hand side. Right? Just a cosine A. Remember? Just a cosine A here. One term only. But over here, what I did was I made it worse. I multiply cosine A over 2, I simplify. Eventually I get to, what is this? 3 different terms. I made it worse. At first only 2 terms, now become 3 terms. So I think we should just give up on this method. If you can find a way, let me know. I'm not gonna continue. I don't think it works.
Am I supposed to remember the identity?
No, don't need.
Okay.
I'm just memorizing it because I just memorized it because I used it so many times. Okay.
Oh no, because I think it'd be very hard to memorize.
Yeah. But eventually, if you go to university, you need to. Anyways, depends on your prof. So what was I saying? Yeah, don't need to memorize, just use the identities, okay, and then learn how to apply it. That should be your priority first. Memorizing is anybody can memorize. How to apply it, that's the difficult part. Okay, question 8 done. Let's move on to question 9. Let's see your answer for question 9. Over here, you very funny. You managed to derive a very famous identity here. It's 4 cos cube A minus 3 cosine A. This is the triple angle identity. We got double angle identity, right? Cosine square A minus sine square A. So you got what? 2 cos square A minus 1 and 1 minus 2 sine square A.
Wait.
Huh? What?
Wait.
Huh? What? Where? Oh, I'm just reciting. Oh, sorry. Here. I'm just reciting. Okay. These guys, right?
Oh yeah. Okay. Yeah.
That was the double angle identity. But what you just did was you derive on your own the triple angle identity. You can go and Google it. It's very famous. You just derived it on your own. Very, very interesting.
But the thing is, I don't really know what I'm doing. I'm just like, I don't know. I'm like I'm trying to do, I don't know what I'm doing.
And that's the nature of Pythagorean identities, and you don't really have a correct direction to go. You need to really trial and error. Okay, need to trial and error a bit. So what you realize is that from triple angle you want single angle, right? So, but then here it's involving tangent square. So how do you link it from how do you link it? Okay, now that you have boiled it down to this guy, which is purely in terms of cosine, right? It's very promising. Okay. You started from the right hand side, right? Am I correct to say that? Yeah, you start from right hand side. But now this guy, let me just rewrite it in the standard format of 4 cos cube A minus 3 cosine A. Now this guy is a very famous identity. It is actually just equals to cosine 3A. And the proof for this part is because of addition formula. Let me show you why that is true. Okay, so let's just say we take a pause here, and we say 4 cos cube A minus 3 cos A. We are stuck. So we pause here, we go back to cosine 3A. So here the trick is whenever you have a triple angle, you want single angle, you can always split it up and use split the 3A up into 2A plus A, and then you use the addition formula. Do you get what I'm saying?
Okay.
Right, you split into cosine 2A plus A, and then you use the formula. So let's just do that. Where should I add the page? I'll add it after question 8. This one I'll just cross it out. Doesn't really work. Let's move on. So start new page. This is question 9, right? Is it question 9? So what is it? Cosine 3A or 3 theta? 3A, right? You can split up as A plus 2A. Right? Then if you recall the formula, cosine A plus B
cosine
equals to
cosine A cosine B minus sine A sine B.
Yep, correct. Oh yeah, no space. Cos A cos B minus sine A sine B. Yep. Okay. Plus is a minus, minus is a plus. Okay, we're just gonna use the addition function. So we're just gonna use that cosine A plus 2A. Now we replace the B with 2A, so it becomes cosine A cosine 2A minus sine A sine 2A. Now over here, there is an issue, which is that look at what you reached at the as a conclusion. It's purely in terms of what?
Cosine.
Purely in terms of cosine. Very right. 4 cos cube A minus 3 cos A. So let's just copy down what you have managed to deduce. 4 cos cube A minus 4 cos cube A minus 3 cos A, and then we're gonna see how we can get wiggle our way back towards just purely in terms of cosine. You see cosine 2A? Cosine 2A. So that means that maybe I should have just used the formula. Give me a second to copy it down. Paste it here. Sorry?
Change to 2 cosine square A minus 1.
Okay, maybe I'll shift it all the way to the left. 2 cosine square A minus 1. Good choice. Why is it a good choice? Because you want everything purely in terms of
cosine.
So don't pick 1 minus 2 sine square instead. Don't pick the sine one. Don't pick 1 minus 2 sine square. What you did was a good choice. Sine A, well, since we can't really do anything to A, let's leave it alone. We need angle A, so you don't go and use double angle identity or anything. Just leave the alone. But sine 2A can be replaced with 2 sine A cos A, right? There's only one identity. So sine should be obvious. There's only one way to do it. But wait, sine A times sine A. So this is read as sine A times 2 times sine A times cosine A. So you can always
2 sine square A cos A.
But you need everything in terms of
cosine.
So what should you do to the sine square?
1 minus cosine square.
Exactly. Very good. So you're almost there, almost there. How about this part? Let's just expand it out. Cosine A times 2 cos square A, that's
cos cube A minus cosine A.
Very good. So let me just copy and paste it so I can be neat. Okay, then after that, you just multiply out the bracket. So you're left with 2 cos cube A minus cosine A. Minus 2 times 1 is minus 2. Minus 2 times negative is positive. 2 times cosine square A. Sorry, I forgot to multiply by the cosine A, so that's wrong. Let me try again. I'll multiply the cosine A in first. Okay, so cosine A minus cosine cube A. Can? Then after that, I multiply a negative 2 in, so negative 2 cos A positive 2 cos cube A. Is that okay so far?
Oh shoot. Okay, actually equals. Then
So 2 plus 2 become 4 cosine cube A. Minus 1 minus 2 become minus 3 cosine A. Hey, equal. What a coincidence. Ta-da, magic. We go magic. Are you amazed?
no.
Actually equals that. Oh, this is magic. Black magic. No, it's just math. Okay, so then you're done. You're done. I don't need you to go and rewind the entire thing and then rewrite it from LHS equals to until this, and then you go here and then there and then there and then there until the final cosine 3a. No, don't need. As long as the middle meets, the middle part is the same, you're done. Square box means you are done. Proof is complete. Okay? Is it okay?
Yeah.
Question 9. Good, huh? Very good. Now, as to, I hope you should realize that for cosine cube A, if you want to go in this direction of the arrow, it's almost impossible. Because you see, the trick here is, if you want to go this direction, you need to take the 4 cos cube A and split it up into 2 plus 2. Why? Who in the world would know you're supposed to split the 4 into 2 plus 2? Who would know that? Nobody would know that. Correct or not?
Yeah, I wouldn't know.
Yeah, I also wouldn't know. Because 4 can be written as what? 1 plus 3, 2 plus 2, 3 plus 1, 4
Yeah.
plus 3 plus 0. And there's negative numbers you haven't considered. And what if you want to introduce decimals? 1.1 and 2.9. You can split a 4 in. So it's impossible, all right? So too many different ways. So that's why we always say you must always start from the more difficult side and work your way towards the easy side. Here, the difficult side is cosine 3a. You might think, hey, cosine 3a looks very simple, but no, you can always split up into a plus 2a, then you expand, right? Then that will be, then you have something to do lah. Got something to do. Okay, understand the intuition?
Okay.
You go this direction, I applaud you and I will ask you, do you have a third eye on top of your 2 eyes? Somebody give you inspiration. Wow, how do you know you're supposed to split the 4 into 2? Divine inspiration. I have no idea. I don't have that. I only know how to do guess and check. A plus 2a. Okay, question 9 done. Let's move on. Any questions? No?
No.
Okay, so for question 10, so you see 6x, right? And you see 1x. What do you think you're supposed to do?
I see 6x and I see 1x. What,
With
split
different
it
powers.
up
Split the
But
6x
as like cosine 2 plus 2x plus 2x plus 2x or what?
2x plus 2x, that's only 4.
Plus another 2x. I don't know.
Plus another, then we don't have the formula for that. We only have, look at the formula, cosine A plus B, only 2 terms. We only allow 2 terms to be added together. You want 2x plus 2x, or 2x is 3x. Sorry, it's 3 terms together. There could be a special identity. You can go and Google and search for it online, but that's not available to us.
3x plus 3x.
Wait a minute. If 3x and 3x is the same, isn't it just 2 times of 3x?
Okay.
2 times of 3x. We got a formula here. 2 times of A.
Okay.
So what can we do to your A? Replace the A with?
Replace the A with 3x.
But you look at the formula at the end of the day. You want everything in terms of powers of? Question 10. Look at question 10.
Yeah, like
powers of? Is it sine or is it cosine?
Cosine.
Cosine. So which one would you want to use? Option 1, option 2, option 3.
Cosine square 3x minus 1.
Very good. Yes, exactly. That's what you're supposed to do. All right. Then after that, cosine square 3x, what do you do? Wow, still too difficult. We want 1x only, but here we have 3x. What do you do instead?
You
cosine square 3x is the same as cosine 3x times cosine 3x, right? But you want 1x. So what can you do to each of the 3x? The 3x you can always split up into x
1.
plus 2x, right? X
Yeah.
plus 2x. Then from there you can split it further because it's x plus 2x, right? That means you can use a plus b again. Correct or not? A is x, then b is 2x. But you have to bracket square the entire thing. Expand this entire thing and square it. So you can imagine that it gets very, very long-winded. Okay. Right? You got the main idea? Get the gist of the idea?
Okay.
You just keep on going down one level, go down one level. 6x become 3x, 3x become x plus 2x, and 2x not enough, you still need to use double angle again to become 1x. So you get the main gist already. Give me a while to bring up my question paper. I need to find my question paper first. Where is it? Here it is. Okay. Then this is what question again? Question 10, right? Okay. Maybe for this entire lesson, I'll just go through all the questions in this paper. Okay. If we have time. All right. Can Okay, you got the main idea now. Let's do it. Implement it. So question 9 done. Let's move on to question 10. Question 10 is super long-winded. Let me just do something. Did the orientation change?
No. Yep.
Yes. Okay. Can. I'm just changing it to portrait mode because I need more space. Okay. Wait. Let me just copy down the identity. Copy. I'll paste it over here. Okay. So what we're gonna do now is we're gonna split our cosine of 6x up into eventually. What's that fella? Let me copy down the question first. 32 multiplied by cosine of x to the power of 6 minus 48 times cosine to the power of 4x plus 18 cos square x and then minus 1, right? Let's do it. Okay, so LHS equals cosine 6x equals cosine 2 times 3x. So which identity? 2 cos square 3x minus 1. Very good. It's optional to put the brackets around the 3x. Then here, please be careful because this is a square, right? So you can think of it as bracket square cosine 3x and minus 1. But we're gonna split this 3x up into x plus 2x, okay? And why did I leave such a big gap? Is because in the next line, I'm gonna replace the cosine x plus 2x with cos A, cos B minus sin A, sin B. So cosine x, cosine B minus sin A, sin B. I need more space. Give me a second to move this. I want to make it look neat. Sin A, sin B. Okay, are we done? No. Look at the angle at the end of the day. All 1x. Here we have 2x. So what should we do?
Double angle formula.
Double angle identity. But
cosine
before
2x. Change to cosine.
Very good. Change to which one?
Change to 2 cosine square x minus 1.
Very good, exactly. Maybe just to make it look extra neat, I'm gonna align it like this. Maybe if I can just bring it over here. And then I'll leave a gap like this. I'll align the bracket square. Maybe I'll bring it all the way to the right side. Okay, so minus sine x sine 2x will now become minus sine x times sine of 2x. But you can always split the sine 2x up into 2 times sine x cos x, right? Is this clear?
Yeah.
No, I don't want to convert. I want to duplicate this guy, bring it back in like this. Is it clear so far? I just move the bracket square over to the right side with a lot of gaps. Is it okay? Can then I'll move on. Now, we have to expand. Okay. Let's leave the bracket square alone first. I'll do that as a last step after I simplify as much as I can. Here inside, I see it's a 2 cosine cube x minus cosine x, and then minus 2 times A. What's this? Doesn't it look familiar?
2 sine square cosine square x.
Actually, you know what? Can I just take a shortcut here? Can I take a shortcut here?
Okay.
Because we realize this is cosine 3x, right? Do we have a formula for cosine 3x that you derive on your own?
Wait, say again.
Do you recall a formula for cosine 3x which you derived on your own?
Cosine 3x.
Previous question. Okay, review answer. Review. Yes.
X plus 2x. What do you mean?
No. 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 Here. Here. Not 3, but it's 3a lah.
Okay.
This guy. This
just
guy.
Bring, yeah. Okay. Just bring.
Then just recycle, right? Don't need to do the work again. It's gonna be the exact same thing, right? Understand? Recycle, reduce, reuse, recycle. Here I recycle my work, so I don't need to redo. I'm just gonna be redoing the same thing. So yes, I don't need to write so many things. Oh my goodness, why did I not think of that in the first place? Sorry, wasted your time. So this is 2 times whatever square minus 1. What is whatever? It's just this guy. 4 cos cube a minus 3 cos a. Sorry, must contextualize. It's not a, it's x. Single x. Then here is refer to question 9. Refer to question 9. It's like a hence question. Is it okay so far?
Yes.
Very good. Now we can continue. So here you got a minus b bracket square. How to expand?
A square minus 2ab.
A square. So it's 16 cosine 6x. Make sense? Square and a cube.
Yeah.
Maybe I can zoom in. Then minus 2 times a times b. 2 times, I'll multiply the number first. 2 times 4, 8. 8 times 3 is 24. Then cosine cube times cosine x.
Power.
Can I just simplify it? Yeah, very good. Power 4. I'll simplify straight away. I hope you're not confused.
Plus 9
Then
cosine
plus
square x.
3 square cos square is 9 cosine square x. Very good. Close the bracket and then minus 1. Okay, are we done? No.
Times 2 throughout, then is equal.
Yes, correct. Very, very good. Okay. So if you didn't have the working from question 9, it's going to be extremely long-winded. Let me just. Okay, and then we're done. Equal RHS to be complete. Equals RHS. Equal RHS. Wow, so satisfying. LHS equal RHS. Proven. Yeah. Okay. Can question 10. Okay, very good. Question 11. Is it different? Let me just copy down the question first. Question 11 is requesting for 2 multiplied by cosecant of 4a plus cotangent of 4a to be identical to what's that fellow? Cotangent a. Am I copying the correct question? Let me see. Cotangent a minus tangent a, right? Wow, so evil. 4a. So we can imagine what identity would we want to use to bridge the gap from 4a to a?
4a to a.
Maybe a good in between. Double angle. A double angle can help us to times 2 divided by 2. Would you want to change this into 8a, or would you want to divide by 2, make it into 2a?
Divide by 2.
Divide by 2. So don't 8a. Then how do you go from 2a to a? You use double angle identity a second time. Okay? It's a coincidence. This is by design. 4 is 4 is really just 2 square, right? That means you can divide by 2, divide by 2. So you can use double angle 2 times. Okay? It was on purpose. Sorry, I forgot to copy. I copied wrongly. This should be cotangent 4a as well. Yeah. Wow. I better make sure I copy correctly first. If not, I go on what do you call it? Go in. Copy the question wrongly, and then I'll just none of my efforts would make any sense at all. I'll be wasting all of my efforts. What do you call it? 闲工什么费? Okay.
My Chinese not good.
Okay, it's all right.
I wish it was.
can go tuition for Chinese. Sure, why not?
No hope already. CLB.
Oh, right. Can, no worries. I have like a few friends in CLB too. You're doing well. Don't worry. So now how to prove double angle lor. Let's see how we can do it. So how do we bridge the gap? We need to use double angle identity. But before we do that, let's take a look at the cosecant and cotangent. Now, I am very scared of cosecant and cotangent when I see co, because I don't really remember the identities. Okay, I only remember that they are the reciprocal of the something, reciprocal of something, 1 over
No co.
Co and no co, correct. So that means that what I'm gonna do is I'll change the question. So I'll deal with the right hand side first, and I'll change the question to something that's purely in terms of cosine and sine. Okay. So what is cotangent A in this case? 1 over tangent, which I know tangent is sine over cosine, so I split it straight away into cosine over sine, right? Then tangent A is sine over cosine, right? Fraction minus fraction. When you got the fraction minus fraction, you have to make what the same?
Fraction minus fraction, you have to make denominator same.
Denominator the same. So how about if we just multiply
Cosine square A minus sine square A over sine A times cosine A.
Very good. Okay. So at this stage, I know what you're thinking. Cosine square A minus sine square A. Cosine 2A lah. Correct or not?
I was not thinking that at all. But yeah, sure.
Okay.
Cosine 2A. Yeah.
Doesn't
Nice.
that work? You see, got 4A.
Yeah, I know. I see. Okay.
Okay, so you can get cosine 2A over sine A cos A. Sine multiplied by cosine. You must be thinking. Okay, should I wait for you? Cosine A, cosine A. It looks very familiar. A product of sine and cosine.
Wait. Sine A cosine
and the
A.
angle is the same. You're taking sine and multiply cosine. Which one?
Sine 2A. But then
Sine
that's
2A, but
sine A over 2.
Sorry?
Wait,
no.
There's no 2.
There's no coefficient 2. So what you're supposed to do when there's no coefficient 2 is to times half on both sides. Does it make sense? So what you're doing is you are multiplying by half. The angle is remaining as 2A. You don't go and half the 2A, okay? It's half outside of the sign. The half is outside of the sign. This is a very important point.
Can I just do this?
Do what?
Like times 2 top and times 2 bottom.
You can do that as well.
Does it make it like harder to solve because the top is like, I don't know.
Actually, that's a good idea, 2 times 2, because if you look carefully at the left hand side, what do you see?
Oh, got 2 on top.
Got 2. So it means we're on the right track if you times 2 top and bottom. Okay, so there's no worries about the 2 at the numerator. Just leave it alone. It's tagging along for the right, but it doesn't affect you. But more importantly, 2 sine A cos A at the denominator can now be replaced with sine 2A. Correct or not? Wow, interesting. Is that useful?
I don't know.
Is that good? Is that bad? I don't know. I really don't know. So we are stuck. What do we do when we are stuck? You just give up?
Left hand side.
You work on the left hand side now. So maybe if I can just present it neatly, I will say RHS equals this, equal this, and then I pause. Now I move on to LHS. Okay, maybe just to be neater, I will be a bit more precise and say cotangent RHS equals to cotangent A minus tangent A. And then everything else underneath. Then I'll just take a break, pause there. Then I'll move on. Maybe I'll leave a gap. So maybe I can have some inspiration and I can continue my working. Then LHS, let's work on it. Copy and paste. And then, we are meeting in the middle with double angle 2A. Here we have 4A. What should we do? Yes, first step, rewrite it as sine and cosine. Right? Sine, cosine over sine. Very good. Are we done? No. Here you need to realize something. Fraction plus fraction, you always make what the same? Make denominator the
But it's
same.
already the same.
But
so
it's
you
already the same, so you just combine straight away. Don't forget the 2 in front. You drop the 2, the question sine 4a at denominator, numerator is 1 plus cosine 4a. How to continue? Then you think and think and think, and you realize, actually the 2 here, safe. It's very good that there's a 2 there. It means we are almost the same as the middle guy. But now the question actually boils down to this fraction here and this fraction there. They are the same. But how do we make them the same? How do we show that they are the same? Then you have to look at the angle. You see the angle here, 4a? You see the angle there, 2a?
Okay, double angle from
Pause there before you continue. You must also think a bit more. Look at the numerator over here. You know the goal already, right? The goal changes to showing this fraction equal this fraction. Look carefully at the numerator. How many terms do you see?
1.
Here got 1, here got 2 terms. So that means that when you use double angle, you better make sure that the +1 disappears. You want to make sure the +1 disappears so that you can only have 1 term. Does it make sense?
Yeah.
That's the intuition. What's the opposite of +1? Who can cancel off +1?
What do you mean? Sine square plus cosine?
No. It's way simpler. The opposite of +1 is
Minus
positive. What? -1. Is that enough of a hint already? -1. You got double angle. So if you want to use double angle on cosine 4a, naturally you have to ask yourself 3 versions, which one to pick? I just told you the hint, right? Opposite of +1 is -1. So which one do you pick?
Minus.
Exactly. You're going to pick cosine 4a equals to 2 cos square 2a minus 1. Okay? You see you're halving the angle.
Okay.
Is that clear?
Yeah.
Right? The intuition behind it is more important than just substituting. Everybody can substitute. Sec 1 kid can substitute. But you must understand why you pick this option. The intuition is 1 term here, 2 terms here. You want to pick the one with a -1 so that they will cancel off. Is it clear so far?
Yeah.
Good. Then we proceed to substitute. Sine 4a, I will substitute later. But before that, let's take a look at this guy. Wow, so beautiful. The +1 and -1, what happens? Cancel away. Very nice.
Wait, so I'm allowed to just do that? Like I
What
can
thing?
write like this?
Yeah, of course. Yes. Yes,
Okay.
you should do that.
I
You should do
will
that.
start doing that because I didn't know. Like I thought, okay.
Yeah, you should do that. You should do that. So you can tell the examiner clearly that, oh, I understand that they can cancel away. Okay, and it looks very nice. Looks very satisfying too. Wow. Cancel away. Okay, then you're left with 2 cos square 2a. But wait, sine 4a can also be replaced with 2 times sine 2a cosine 2a, right?
Mm-hmm.
Are we there yet? Not really. Look carefully again. 2 times this fraction, 2 times this fraction. I think you can tell we're almost there, right?
2 times this way.
You can ignore the 2 in front. I mean, maybe I highlight it in light blue.
Okay.
Let's just clean up a bit. Maybe it's a bit confusing. 2 times. After you cancel away, maybe if it's still messy, just rewrite it in the simpler format, like this. Bracket, bracket. Okay, times 2 in front. Right? Anything else to cancel? Here you can read it as 2 cos square, 2 times cosine square a, 2a, sorry, and 2 times sine 2a times cosine 2a. So it's like 2 times cosine square is really just cosine 2a times cosine 2a, 2 copies of it. If it's cos cube, then 3 copies, cos power 4.
Cancel.
And very good. Yes. That's what I'm waiting to hear. Cancel away the common factors. You realize the cosine 2a cancels away, and 2 also cancels away. The 2 being from the numerator. I mean, from inside the bracket. So at the end of the day,
Oh,
yes,
okay.
they are
Yeah.
the same.
Oh,
Okay? Convinced they are the same?
yes.
Since they are the same, I'm just going to be lazy. I'll copy and paste whatever we've written previously. Okay? Can? To make it look extra convincing. Wow, it looks exactly the same. Must be true. We have proven it. Okay? Can? Maybe I'll just cancel inside the fraction as well. Here, cancel. There, cosine square cancel away with one copy of cosine 2a. So you can do that. The 2 cancel away with the 2 cosine 2a. It's a bit like x square over x. You can cancel off the x, maybe a y in front. Cancel off the x and the 2 cancel away like this. Same idea. Okay?
Okay.
And proven. So done. I don't need you to show me from LHS, walk all the way here, and then from here all the way upwards until you go to the RHS. You don't need to climb the waterfall. No need. Waterfall drop downwards. I don't need you to go up against the flow of the waterfall. Against the flow just doesn't make sense. It's very unnecessarily difficult. Okay? Yeah, just meet in the middle is fine. The middle is the same. And you're done. Question 11 clear. Let's move on to question 12. Okay, let's see. Question 12. I should start a new page. Wow, this is taking a lot of pages. Wait a minute. Let me reformat this a little bit. Okay. I don't want this. So this space was wasted. I don't need that wasted space. Can I just shrink my handwriting a bit? Okay, shrink it down, bring it up. Done. Next question. Let's go to question 12. Let me copy down the formula first for reference. Put it at the corner. Okay, question 12. Let's copy down the question first. So tangent A plus tangent 2A is equal to or identical to a fraction. So I should bring my handwriting down a bit. Fraction right along the line like this. And sine A multiplied by 4 cosine square A minus 1, all divided by cosine A sine 2A. How to continue? Which one looks more complicated to you?
Right.
Okay, let's work with the right hand side. Copy and paste first. What should we do? Let's look at the begin with the n in mind. Look at the left hand side. You want single A and a 2A here.
Okay. Change this thing to the double angle formula. Like, wait, what am I saying? Wait, no, wait. I'm gonna
4 cos square minus 1 is not the same as 2 cos square minus 1.
I know, no, yeah, I just realized.
Yes, correct.
Oh,
got bracket, right? Got bracket with 2 terms inside. Then what should you do?
expand.
Multiply? Yes, exactly. Just do it. So let's see. 4 sine A cos square A minus sine A all divided by, let's see, cosine A sine 2A. Okay, fine. This question is challenging because there's a 2A here. So maybe it would be a smarter idea if we just meet in the middle where everything is simplified in the simplest term. So in other words, maybe the 2A, we don't deal with it. We split it up into 1 minus 10A, 2 10A over 1 minus 10 square A. Right? Use the double angle identity so that everything is purely in terms of tangent. A. Everything is just a 1A angle. Is that clear to you?
Yeah.
Okay. So actually, let me think a bit. And then actually, I don't like tangent 2A formula because fraction very scary. Wow, fraction really painful. You need to substitute with sine over cosine, sine square over cosine square. Maybe a smarter way is instead of using this formula, we avoid doing that. We just substitute tangent 2a and tangent a with sine a over cosine a, sine 2a over cosine 2a. Right or not?
Mm-hmm.
Oh, then let me see. Oh, perhaps it was not such a good idea to expand. You are right, actually. When you were saying 2 cos square a minus 1, you wanted to use, you managed to recognize it's a 2 cos square a minus 1 pattern. Yeah.
But it's not the same.
But it's not the same. But we can make it the same almost by splitting this 4 copies of cosine square into 2 copies plus 2 copies. Okay, okay. Because I have the answer key, that's why. This one, nah, don't do it. It's gonna lead down a very bad rabbit hole. I'll save your time and tell you that won't be a good procedure to simplify it. Instead, you should split this up as 2 cos square a, 2 cos square a. So let me just do some surgery over here. 2 cos square a plus 2 cos square a. Add them together and you get the following, like this. Is it clear?
Mm-hmm.
Like this? Agree, right? 4 cos square a is the same as 2 plus 2. Don't ask me why I know I have to split into 2 plus 2. Okay, the intuition behind it is I want 2 cos square a minus 1. So I can replace it with cosine 2a. Why do I know I want cosine 2a? It's because of the tangent 2a here. I want double angles. Right? Is that fair enough? Can
Yes.
Okay, good. Then just multiply sine, just substitute in 2 cos square a, leave it alone first. But 2 cos square a minus 1, if you recall the identity, it's really just cosine 2a. Close the bracket, or divide by cosine a sine 2a.
Expand
Okay.
then cancel.
Wait, sine a over cosine a, that's a tangent. But problem is that this tangent is a single term. This tangent here is a factor. It's a factor. It's not the same. So should we expand out and then we try to cancel?
Yeah, expand and cancel.
Yeah. Okay.
2 cosine yeah.
2 sine a cosine square. I'll just keep it in the same order. Plus sine a cosine 2a, all divided by cosine a sine 2a. Now at this stage, you cannot cancel off like you see a here, you see a here, you cancel. You see a 2a, you cancel a 2a. No such thing. You need to factor out a common factor first, then you can cancel. But here you realize that there is no common factor that's common among the numerator and denominator. So what we can do instead is to do a special trick.
What?
Do you agree that 3 plus 5 over 7 is really just 3 over 7 plus 5 over 7?
Okay. Yeah. Okay.
So we can split.
Okay.
You get what I'm saying, right? Just split the fraction. So let's do that over here and over there. Let me make it look neater a bit. Like this. Okay?
Yeah.
Okay? Good.
Yeah.
So anything to cancel now? Let's zoom in and see.
Yes. Cancel is.
Which one? Yes, correct. Cosine A, cosine square. So you're really just left with what? You're really just left with for the first term.
Change sine to a use double angle formula. Become what? 2 sine a times cosine a, is it?
Yes, correct. Or you could also substitute the numerator with sine 2a. I'm gonna do that because there's less things to write. You can always go in the opposite direction. Right?
Wait, how do you do that?
No. Sine 2a, you can replace sine 2a with 2 sine a cos a. Or you could also replace 2 sine a cos a with sine 2a. Of course, it's an equal sign, can go in both directions.
Oh, no, I just didn't recognize that this was
Yes, this guy is sine 2a, right? Then they cancel off, it becomes a 1. But is that a good idea? Let's just write it down first and we'll think later. Plus 1. Plus. Here the other guy, anything else to cancel?
You can change sine 2a into 2 sine a cosine a.
Okay, can. Let's do that. Sure.
And
This is
cosine
different from my answer already, so I have no idea if it works or not. Let's just do it. 2 sine a cos a. Yeah? Okay. Then I noticed that sine a can cancel. Right? So let's simplify that first before we continue. I know there's a cosine 2a, but do we want to get rid of do we really want to get rid of the 2a? If you look at the question, it's saying
it was got 2a on the tangent
2a. Ah, very good. But over here, please don't, this guy and that guy, can you cancel?
No.
No, they're different. This is angle inside is 2a, this one is cosine single a. Cannot cancel. Then how? But what's cosine times cosine?
Cosine square.
Yes, cosine square a. So maybe we can simplify this into 2 cos square a. Is that useful? Actually, I need you to pause now and take a look. What we have just created is a monster 1 plus. It looks simple, but that's not what we want. Look carefully at what we want. Oh no. I think we went down a different direction already. It's like you're lost in the forest of math and there's a fork. We took the path that seems to work, but I think it's a bad path because 1 plus is not what we want. We want tangent A, we want tangent 2A. So we are stuck. Do you agree that we are stuck? So what should you do when you're stuck?
Left-hand side.
Left-hand side, very good. Okay, let's start with the left-hand side now. Yeah, let's work with the left-hand side. So let's just break everything down into sines and cosines instead of using double angle identity on the tangent, which will be very painful because there's a fraction. Let's just break it down into sines and cosines. So what we have is sine A over cosine A and sine 2A over cosine 2A. Is that okay? There so far? Very good. Then when you got fraction plus fraction, you want to add fractions together, what do you have to make the same? Denominator. So of course, adding the fraction together, you get the common denominator will be cosine A cosine 2A. Without substituting the sine 2A, without substituting the cosine 2A. Let's just try that, okay? To make our life easy. Let's see where it takes us. See if it works. I don't know. Then we get sine A times cosine 2A plus, let's see, what is this? Sine 2A times cosine A. Agree so far?
Yes.
Very good. Let's start to compare with the left-hand side. Just now we had cosine. Just now we had what is it? Cosine A sine 2A. Now it's cosine A cosine 2A. Did I copy the question wrongly? Let me double check the question. Yes, no wonder we are lost all the way. I copied the question. Yes, I copied the question wrongly. I'm so sorry.
Lol. Okay, that's actually fine. I'm okay with it.
Sorry. Let me just correct that. That's not good. That's bad. That's cosine 2A, so this is wrong. No wonder we let down. We are in such a different path. Can I just erase this? Right. Then then in that case, let's just continue the right hand side because I see something. Cosine 2A, cosine 2A. Can cancel it.
Become tangent.
Besides tangent. Very good. We're almost there. How about the other guy?
Change cosine. Change cosine 2A.
Change cosine 2a into what? Nah, no, shouldn't do that. Let me simplify it for you. I think you can tell by the time I simplify. Hopefully, I don't know.
Change the top. Change the top to sine 2a.
Exactly, and then we're
Before
done.
tangent 2a.
Very good. Yes. Oh, so it was because I copied the question wrongly. No wonder it was so difficult. Yeah. sorry. Copied the question wrongly. Of course, it's unsolvable. So this is a demonstration of a common mistake. Yes. Copy the question wrongly, you're not gonna solve the question. Okay. And then we're done. Okay, don't even need to work with left hand side. Okay, good. Start from the complicated, work towards the easy. Yes. So what did we learn here? What we learned here is that sometimes it is smart to not be in a rush to substitute the double angle with the single angle identities. Sometimes it is better to leave it alone. Like in this case, sine 2a over cosine 2a is just tangent 2a. Okay, that's the main thing we can learn here. Don't sub the cosine 2a with any identities more efficient. As to how you can figure out when you should substitute and when you should not, you should always look at the left hand side on the right hand side. The left hand side here, there's a 2a, right? So it means we need to keep some of the 2a's. So that serves as a inspiration for you to know that, okay, maybe I shouldn't be in a rush to replace cosine 2a with all the single angle identities. Maybe I should keep it. Okay, but usually at the end of the day, I say inspiration. I didn't say it will confirm work. You still need to do guess and check. Pythagorean identities. Okay, not too easy, Pythagorean identities. Okay, moving on. Yeah, let's go on. Question 13. Let me paste the question here. Is it right? Yeah, here. Okay, what is the question number? Question 13. I better make sure I copy it correctly this time. Sorry, in the worksheet, there are some questions which were repeated. I think it's question 14, 15, 16, and 17. 14, 15, 16, and 17 were repeats of 4, 5, and 6, I think. 3, 4, 5, 6. So yeah, we skip 14, 15, 16, 17. So question 13, let's take a look. How do we solve this? This should be a bit easier. What do you see here?
How is this easier?
What do you see here?
Okay, change to
You see tangent square, secant square. You're gonna substitute with sine. Let me think a bit. Is this the most efficient way? Let me check first.
okay, fine. Change tangent to secant square minus 1. Oh.
Yes. LHS equals, let me just copy down what you're writing. Substitute the tangent square with secant square minus 1, right? Why do you want to do that? Because you see secant square here, and you look at formula list A, tangent square is related to secant square. Okay, so tangent square replaced with secant square minus 1, multiply out, you get 2 secant square theta minus 2 minus 1. What's minus 2 minus 1? It's just minus 3, right? So it's equals to RHS, and then you are done. Easy, right? Yes, easy, very good. So you just need to see the squares, and then you realize I should use these identities. And don't be in a rush to replace everything with sine and cosine. Sometimes it's more efficient to keep the tangent square, keep the secant square. You need to see that you are trying to link secant square with tangent square. Then you hopefully can realize that it's the second identity. All right, Ken?
Okay.
Substitute tangent square theta with secant square theta minus 1. Okay, that is question 13, 14 until 17 is a repeat, so we ignore that. Then let's move on to question 14 to 17, and let's move on to question 18. So 18, what does it say? Cosine, let me copy down to be, let me just copy down the question first. Cosine cube x cosecant of x, and then you want to show it's equal to cotangent of x. Yeah, correct. Okay, so now let's deal with this. Can you tell me which one looks more complicated, left hand side or right hand side? Left hand side. So let's work with the left hand side first. We want to work our way towards cotangent x. Maybe we just deal with the right hand side a little bit here. First, cotangent x, maybe we can rewrite it as cosine x over sine x. Perhaps it's even 1 over tangent x. Which one is more useful? I have no idea. But then I realized that here got cosine, here got sine, here got cosine, here got odd one out cosecant. Perhaps it would be better if we just use everything in terms of sines and cosines. Okay, so over here, we leave it as cosine over sine. You know why it's cosine over sine, right?
Yes.
Because tangent is sine over cosine, which means 1 over it. Flip it around. Very good. Okay, so let's work with the left-hand side. Copy and paste. And what do you want to do? What do you think? Pause a while. Let's think about it. Here on the left-hand side, how many terms do you see?
2 terms.
How many terms do you see at the end of the day?
1 term.
1 term. So what do you think happens? How come 2 terms become 1 term?
How come 2 terms become 1 term?
Yes. You probably need to factorize.
Oh, okay.
Factorize. Or maybe it's a fraction plus a fraction. Then you need to combine fraction. Unfortunately, over here, cosine x, sine x, can you rewrite it as a fraction? Over 1? Maybe?
I feel I can.
Should be.
I feel like
over 1. Over 1 is the only possibility.
Sine 2x over
Oh. 10.
plus
But please pause a while. That's a very bad idea.
Okay.
You want to have 1x at the end of the day. You change it to 2x. You're leading further away.
Okay.
True, but not very relevant. So let's just leave it alone first. Cosine x plus cosine x times sine x. Can't really do much yet. So cosine cube x and then cosecant is really just 1 over sine, right? So it's over sine x. You realize you got cosine x sine x plus a fraction. You can always rewrite this cosine x sine x as a over 1.
Times sine.
Now you got fraction plus fraction. What should you do? Add times sine x.
Cosine x sine square x plus cosine cube x over sine x.
Very good. Got square. Then what do you do? Perhaps before you continue substituting, you should look before you leap. You see denominator sine x?
Yes.
You look at our end goal. Do you see sine x as well?
Yes.
So what does it mean about the numerators? They must be equal.
The same. Cosine x sine square.
So you just need to show that this fellow is the same as that fellow. So you need a cosine x, right? And hopefully, I hope you can see that there's a common factor of cosine x. You can factor out.
Yes.
So we factor that out because we look at our end goal first.
Equal to 1.
Very good. Yes, it's 1. You see, if you proceeded to substitute sine square with 1 minus cos square, you're not going to get the answer. Do you see that?
Yeah.
Don't be in a rush. Don't be in a rush to substitute with whatever you see. I can substitute. Then you just substitute. No. Look before you leap. Look at your conclusion. What do you want? Cosine. Then you substitute. Then you factorize. Okay, so sine square x plus cosine square x because you factor out 1 copy of cosine x, and then of course that guy is just a 1. So cosine x times 1 over sine x. You can, and of course it's just cotangent x. Clear so far? The main moral of the story here is look at RHS before rushing to sub sine square x equals 1 minus cos square. That's not so efficient. The more efficient way is to just factorize and then substitute with a 1. factorize and then substitute with 1. The why we factorize out the cosine x, okay, I guess is it fair if you don't look at RHS, can you tell that you're supposed to factorize out cosine x? Just a genuine question. I don't know. Do you think
I don't know.
Don't know. You won't see that.
I don't know. I actually don't know.
Oh, don't know. Okay. Practice the questions and you will see. And then you will see lah. Huh? Should I continue going through or should I let you practice? And should I go through new topic now? I think trigo analysis. Huh?
By the way, we haven't go through the paper 2 for the what is it?
Oh right. You're correct. The Swiss cottage. Right. I'm so sorry.
We can just do another time. I'm just saying only.
Okay, can. I think maybe it's more worth it to go through the trigo analysis because the paper 2 topics you already know. Yeah, maybe okay, since we have 13 done, sorry, 18 done. I think we should just go through all the questions. It's better that way. But then how do I assign homework then?
You can use the textbook.
Use the textbook? I think the textbook questions are easier than this.
Oh, okay.
Okay, I will leave cosine. Okay, can you help me to record this down somewhere? Question, I'll just type in the message. In Telegram. Question 19, I'll assign as homework. Okay.
Okay.
What other questions? Let me look through first. Question 19, you just need to use addition formula. Okay, I'll leave it to you. Sin A plus B. So sin A cos B plus cos A.
Wait. I'm sorry to write this down.
Oh no. I'm typing. Question 19. I just sent to you.
Okay, yeah, I see on the
question 19. Yeah. Trigo proof. Let me just make it look nice. Question 19. I can edit this. Okay, good. Question 19 and question 20, 21 should be fine. I'll leave it to you. Question 22, 23, 24 all look very okay. Just 24 have to be a bit careful with the triple angle cosine 3x, right? You know a formula for cosine 3x already? Question 24? Please make use of it. Feel free to use it. Okay? The triple angle identity. So question 19 to question 24. And then question 25, I think I'll go through. Or you want to do as a challenge?
No, I'm good.
Question 25 is the exact value of cosine 18 degrees. And the amount of work that is required to get the exact value is extremely long-winded. Let me just I'll go through it. Okay, I'll go through it. Just let you see. Yeah, let me just copy down the question. The rest will be homework. Question 19 until question 24 is homework. Let's move on. Question 25. Wow, 25, 6, 7. Let's just go through that. Yeah, then maybe I'll also assign the Xingli papers as homework. Okay, I think. Wait, why did I write 5? Should be 25. I think landscape should be enough space. That's not right. I should no. I should keep the portrait. Sorry. This is super long-winded. Let me just write down the question that we are trying to prove. The identity we're trying to prove. Cosine 18 degrees is exactly equals to the square root of 10 plus 2 times the square root of 5. Square root the entire thing, all divide by 4. Do you want to quickly type in a calculator and tell me what's cosine 18 degrees? Could you help me to do that?
Yes.
Make sure your calculator is in degree mode.
Cosine 18 is
yes.
0.95105656163.
Yeah. Okay. Then can you key in this this fraction inside your calculator as well? Check that it's the same.
Yeah, same.
Same, not a coincidence. Okay, now we're gonna prove it. We're gonna try and prove it. Okay, so key observation here: 18 degrees and okay. What's cosine 90 degrees first? What's cosine 90 degrees? What is cosine 90 degrees?
1. Minus
Ah,
1. Wait.
90, 180, 270, 360.
I mean, 0.
0. Very good. Yes. Then can you see the relationship between 90 degrees and 18 degrees? Times what?
5.
5, huh? So that means that if we can start off with cosine 5x and we somehow rewrite it in terms of cosine x, we could solve for cosine x, right?
Okay.
We substitute x with 18 degrees. And then cosine 5x will be cosine 90 degrees, which will just be a number. It will just be a 0. And then we can solve a certain equation, right? For cosine 18 degrees. You can treat this as x. Hopefully a quadratic equation, because you see a few square roots, right? You see the square root 10, square root 2 root 5?
Yeah.
So that means it's related to quadratic equation. Can you see that? Okay, with that in mind, our goal now is to find an identity linking cosine 5x to cosine x. Yeah, that's one way to do it. Maybe there are other approaches you can find online. Like you need to use the exponential rules and stuff. I mean the complex exponential, but yeah, we don't need that. So let me just write down the thing. Can I just start off with the conclusion before I go on to the proof?
Okay.
Sorry, the surprise. No surprise. Cosine 5x is actually just exactly equal to 16 times cosine to the power of 5x minus away 20 cosine cube x. And then you add on 5 copies of cosine x. Okay? You want to verify that? Let's try x with 2 degrees. Then 5x will be what? 10 degrees, right? Try typing cosine 10 degrees. What do you get?
Cosine 10 degrees.
5x, where x is equal to 2 degrees, for example. Oops.
I get 0.9848.
Okay, good. Same. So cosine 5x is cosine 10 degrees is approximately 0.984. Now, can you try typing in this expression here in the calculator, but you replace the x with 2 degrees? Do you know how to type cosine 5 power 5x?
No.
You type it as this, open bracket, cosine, open bracket, what's this? 2 degrees, right? So type 2, close bracket, then power 5. Likewise for all the others. Okay.
Okay.
Tell me what value you get.
I get 0. I get the same thing basically.
Very good. Okay.
0.98480775.
Very good. Okay, so that means the formula is correct. Then let's proceed. Oh, sorry. Where is it? This guy. Let's proceed to prove it. Let's proceed to prove that formula. That horrible formula. Let's go. So, if I left this as a homework to you, would you have been able to think of this? You need this formula.
Of course
No
not.
way. Okay. So yeah, I should go through now. Yeah, I definitely should go through this. Okay. Maybe you can if you try hard enough. I don't know. Okay, let's just go through this. So now cosine 5x equals to that funny formula. Let's try to prove it. So you see that 5x and a 1x. How do you break it down? What was the trick? If you recall the 3x one, cosine 3x. What do you do?
X plus 2x.
Very good. So what do you think we should do with cosine 5x?
Split to 3x
How about
plus 2x.
can I suggest 4x plus x instead?
Okay.
Both works, both will work. But I prefer this because I already did it beforehand, and that's what I chose to do. 3x plus 2x will also work. I guess I'll leave that as a homework to you. You can also go along that path.
No,
Try on your own. If you try, then just if you want to let me mark, I will mark it. Okay, so let's just use this cosine A plus B. I hope you remember the identity. Okay, don't need to remember. Just know that there's the identity over at the side. I'm just going to use it. So cos A plus B is what? Cos A, cos B minus sin A, sin B. Cos A, cos B minus opposite sign. Plus become minus sin A, sin B. Very good. Not done yet. I need more space, so I'm going to squeeze it all the way to the left. Now, cosine 4x, sine 4x, that's not what we want. We want 1x. So what can we do? How about if we rewrite the 4x as 2 times 2x? Right, it's double of 2x. So we can always substitute cosine 4x with 2 cosine square of 2x minus 1. Right?
Mm-hmm.
And then you times cosine x. How about sine 4x? You can also treat it as double angle. So 2 copies of 2x. So 2 sine 2x cosine 2x sine 1x. Clear so far?
Mm-hmm.
Can very good. But we actually want 1x. Again, I'm repeating. You want 1x, but here is 2x. So what can we do?
Double angle
Double
formula.
angle again. So now we end up with 2 times cosine 2x square, cos square 2x cosine 2x square minus 1 square bracket times cosine 2x minus 2 sine 2x cos 2x sine x. But here I purposely left a blank space because I'm going to replace the cosine 2x with, what is it? Can you tell me?
You replace it.
It's cosine 2x, but you can replace it with? Replace with?
Replace with cosine 2 cosines. Wait, what? Wait.
Yes. 2 cosine square. Yes, carry on.
2 cosine square x minus 1.
Very good. Yes, just the key learning point here is just 2x must change to 1x. Okay, inside the black color bracket. Clear? Okay, just to make it neater, I'm just gonna directly replace it like this. Okay, good. I'll expand it later. Remember, the objective is to express everything in terms of cosine, right? But over here we have like a cosine, which is good. Cosine, which is good. But here got sine. Here got sine, and also double angle. So what should we do?
Change.
Double angle again, right?
Yeah.
So let's just do it. Replace this. The coefficient 2 remains, unfortunately, but the sine 2x can change to 2 sine x cos x. Agree so far? This part is the same as this part. Not done yet. Now you got cosine 2x sine x. Maybe I'll just write down the sine x first to be neat. And then the cosine 2x, we can do something. Actually, you know what? No. I'll just put it at the side. Cosine 2x, which one do you want to pick now? You want everything in terms of cosine. So what should you substitute cosine 2x with?
What do
Three
I
options. Three options.
I change it to 2 cosine square a minus 1.
X minus 1, not a. Okay,
Right.
substitute in. Let me increase the font size and change to black color. Make sure you have a pair of brackets around it because it's 2 terms. Right? There are 2 terms here, so you must have a pair of brackets. 2 or more terms must have bracket. 2 or more terms must have bracket when you're doing a substitution. Right? The cosine 2x initially don't have bracket because it's just a single term. But after you substitute, there are 2 terms, 2 or more terms, then you better put brackets. Have to put brackets. Is it clear? The bracket. Okay, very good. Carry on. Now, problem. We want everything in terms of cosine, right? But here got sine and sine. That's no good. What should we do?
Cosine.
Sine times sine becomes sine on its own cannot do anything, but sine times
sine equals to sine square equals to 1 minus cosine square x.
Very good. Yes. So let's do that. So substitute in, and then the sine x and sine x, I'll just bring it over. I'll just change this into sine square to show a bit more working. And then without expanding anything, I just substitute with the 1 minus cos square first before I carry on. Then everything is now in terms of cosine. Very good. We just need to carry on and prove that it is the same as this value here. Expand everything out. Is it clear? Of the procedure? Okay, let's carry on. So now, yeah, I'm just gonna do it. Just do it. Now it's just algebra. Okay, I'm gonna turn back to landscape so I have more space. Okay, just algebra now. Our objective. Let me copy down the objective at the bottom so that I can keep so that I can know what we're trying to compute. Yeah. So let's multiply this out. You should know what you're trying to compute first before you try to expand. So in case you make any careless mistake, you can immediately spot it. Okay, so expand the square, you end up with 4 cosine 4x minus 2 times 2 times 1 is 4. Cosine square x plus 1 square is plus 1. Close the bracket, minus 1. Square bracket around it times cosine x. Can I just skip a few steps here? Who I'm gonna times in, then I will end up with 8.
8, 2.
2. Okay, good. So the 2 times in already. This round bracket no longer matters, so I'll erase the round bracket. Plus 2 minus 1, erase, it becomes a plus 1. Then don't forget there's a square bracket around it, then times cosine x. Okay, this one I don't erase. I'll just copy and paste this, and then I multiply in. So erase away cosine, now this becomes cosine power 5, cosine power 3, 1 times cosine. Okay? Minus bring down, minus bring down. 2 times 2 is 4. Leave it alone as a 4. I mean, simplify it as a 4. Then now we got cosine x times this fellow times that fellow. Wow, painful. Sorry, I wasn't looking at your writing.
No, I wasn't writing anything important.
Okay, then I'll just carry on. So now 2 times 2 is 4. Cosine x, I'll times in, end up with 2 cosine cube x minus cosine x, then times 1 minus cos square x. Then you multiply in the 4 first before I continue. Can I just do it first? So 2 times 4 is 8 minus cos x become minus 4 cos x. Then I proceed to multiply. So don't forget there's a minus in front. Later must bring the minus back in. Square bracket don't need anymore. So 8 times 1 becomes 8 cosine cube x. 8 cos cube times minus cos square becomes minus 8 cosine power 5x. 3 plus 2 is 5. Minus 4 cos x times 1 is minus 4 cos x. Minus 4 times minus become plus
4 cos cube x.
Don't forget there's a minus inside. So we need to multiply in. I'm just going to copy and paste everything and duplicate it. Then I bring the minus in. So become minus, plus, plus, minus. Is that okay? Clear so far? Can? Good. Then we combine. So like terms combine. 8 copies of cos 5, 8 copies of cos 5. That's 16 copies of cosine power 5x. Minus 8 copies of cos cube. Oh my goodness, sorry, let me do something.
Okay.
Sorry. Yeah. Okay. Anyways, what was I saying?
Yeah, equal
Sorry.
and like
Prove. Let me just copy and paste it then. Okay. Yes. It looks exactly the same, right? So nothing wrong. Hopefully. Yeah. Okay, can ready to continue? Okay, very good. So let's write down the identity again, but which we have already proven. We're gonna use this to show that cosine 18 degrees is equal to that fellow over there. So let's see. So what happens if we substitute x with 18 degrees? That means that we will end up with cosine 5 times 18, which is 90 degrees, which is equals to 0. Good.
0.
And then 16 times cosine 18 degrees power 5.
0.
0. What thing 0?
The whole thing.
Why is yes, the whole thing is 0, of course. Yes. Then cosine cube 18 degrees plus 5 cosine 18 degrees. Okay. Now our objective is not to know that is to realize that actually we can do a clever trick here. We can let x capital X, okay? Look carefully. This one is capital X equals to cosine 18 degrees. Okay. So that means we end up with 16x power 5 minus 20x cubed plus 5x equals to 0. Wow. Amazing. Why? Factor of x common to all of them. You can factor out the x. You're left with 16x power 4 minus 20x power 2 plus 5. Agree so far? Now, when you have a factor times another factor equals to 0, can you solve for x? Yeah. Each factor equals to 0. Equals 0 or the other guy equals to 0. But clearly, over here in this solution x equals to 0, cosine 18 degrees is not 0, right? Because we know how the cosine graph looks.
Reject.
We know how. Yeah, so we reject straight away. Okay, it should be positive. We are expecting, what are we expecting? Let's draw the graph first and write down our expectations. This is cosine graph. Here's 90 degrees.
Less than
18?
1. Less than 1 more than 0.
Very good. Yes. Let me just chop this off and draw it nicely. Correct. Yes, the 1 is there. 18 is a bit less than 1, so 0.9 something. Okay. So you expect it to be positive, more than 0, less than 1. This is our expectation.
Yes.
And this is clearly wrong. So we reject. So that means that we are now back to this kind of equation. What is this? Look carefully. What is this? Power 4, power 2. Our goal is to solve for capital X, which is cosine 18 degrees.
Calculator.
No.
No.
Calculator don't have power 4 function, right? Only GC have, but that costs $200.
No, have.
Have power 4. Wait, have wait, let's see. Don't have. No, my calculator don't have.
I'm using the is it this?
97. Oh, I got power 4. Okay, but let's just do it a more traditional way, which is x square here, x power 4 here.
I don't know how to do.
Can. What if we let introduce another letter, let y equals to x squared? Then what happens? What's x power 4 now?
Cubic.
No. How do you link from power 2 to power 4? Times 2, right? So this is 16. Y
square.
Y square, very good. Yes, y square. Okay, then this is minus 20y plus 5 equals 0. What kind of equation is this?
Straight line. No, I'm just kidding. Y equals 0.
You see, the goal of this question is not to get a decimal approximation, okay? If we wanted decimal
But
approximation, we'll use
there's
a
no
calculator.
exact. There's no exact. I cannot get.
Why not? X equals to negative b plus or minus square root of b squared minus 4ac all over 2a. Quadratic formula.
So you cannot just calculate.
Cannot use calculator because our objective is a exact value over here, exact value.
Okay.
So let's do that.
Oh,
so
that's why it looks like that. Okay.
yes, correct. That's why there's a square root. There's so many square roots. It's because it's a quadratic equation. I said that at the beginning, if you recall. Negative b plus minus square root b squared minus 4 times a times c all divided by 2 times a. Then you try to simplify it manually. Minus minus become plus, plus minus square root. Wow, this one, let's just use a calculator for this. Okay, but of course you understand that it can be calculated manually without a calculator, right? So it's 1280.
I'm not
Right?
gonna lie. I completely forgot quadratic formula existed.
Okay, now you know. Right? Now you know. Hey, did I calculate wrongly? I think it's 80. Oops. Let me double confirm first. Is it 20 square minus 4 times 16? It's 80. Sorry. It's 80. Oh my goodness. Okay, then we can simplify 80 a bit. So this is like 4 times 20. 20 is like 4 times 5. So that's really just 4 square times 5. If you take square root 80, it's the same as square rooting everything. Square root 4 square, square root 5, which is just 4 root 5, right?
Yes.
We are left with 20 plus minus 4 root 5 all over 32. Simplify, split it up. 20 over 32 plus minus 4 root 5 over 32. Now simplify a bit more. 20 divided by 32 is really just 5 over 8. Divided by 4. 4 divided by 32 divided by 4 on both sides, it's 1 over 8. So square root 5 over 8. Ayya. Problem. How come got 2 possible answers to y?
Cause y is like, cause I don't know. It's like,
Don't know. It's just algebra. I have no idea. Maybe there's a meaning to it. You can find out later. But here, all I'm interested in is to solve for x. Solve for
both in.
x. Sub both in. No. Let's just pretend that we know that. Let's pretend, okay? Now, okay, don't need pretend. Square root 5 definitely must be in between square root, in between numbers that are smaller than 5 and smaller than 6 when you take a square root, right? So how about if we pick a good number, let's say 1, how about maybe 4, and we pick another good number, which is, let me think, 9. Do you agree that square root 5 is in between square root 4 and square root 9? Which is really just 2 and 3? Very good. And in fact, it is 2.23. Let's pretend we live in a world where calculators haven't existed yet. So we can only approximate the value. Let's say we didn't know it's 2.23. We know it's in, but we definitely know it's in between 2 and 3, right? Yeah? Okay. It's square root 5, not square root 3, not any other value, square root 5. So what does that mean? It means that if we have something in between 2 and 3, how about square root 5 over 8? Square root 5 over 8 must be in between 2, 8 and 3, 8, right? Can you agree with this statement?
Yes.
You agree with this statement? This is 1/4, which is around 0.25. Not around, it's exactly equal. This one is 0.375. Okay. So how about 5 over 8? Okay, actually, wait, hold on. I don't need to do so much. This is more than 0. Agree so far?
Yeah.
Now, we're gonna take now what we currently have is y equals 5 over 8 minus square root 5 over 8, which is okay, or we also have y equals to 5 over 8 plus that other guy. Our objective now is to check the value of these guys. I'm just going to use a calculator now. I realized that this is approximately 0.3454. This guy is approximately, let me double check, 0.9045. Okay, that's using a calculator, so I cheated a bit. Which one do you think should be the accepted answer for us to solve for x? Because you know the last step, right? The last step is to solve for x, which is just the square root of y. And you reject the negative root, of course, because x is cosine 18 degrees, which is a positive value.
Yes.
Then yeah, then after that, we need to simplify the square root y. But before that, we need to figure out which one should we take. Which one should we take?
Right.
Right one. So maybe why?
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 Yeah.
Don't know. Okay, let me give you an explanation. Okay, so okay, sorry. Actually, I shouldn't have talked about this approximation of the square root 5 value. It doesn't matter. It doesn't matter. Yeah, you. I think the main point here is that the main point behind this estimation is that if you multiply throughout by negative, you end up with this guy, right? Negative 3/8, negative 2/8. And hopefully you agree with me that the direction of the arrow must be flipped when you multiply by negative. Yes?
Good.
Yes, okay, good. So what does that mean? It means that now if I just add 5/8 to all sides of the expression, right? 5/8 minus 3/8, 5/8 minus 2/8. What I just did was I added 5/8 throughout the inequality. The left hand side is 3/8 now. The right hand side is 2/8. Sorry, I forgot to put a more than symbol over here. Okay, let me just change the font size so that it's consistent. And I'll shade this in orange. I just added 5/8 throughout the inequality. Previously, I multiplied by -1. Is that okay?
Yes.
Very good. So now what you realize is that this expression here is in between 2/8 and 3/8, which means that it is positive, right?
Yep.
So that means that you can, and in fact it is 0.3454, but we know that this is in between 2/8 and 3/8. It's in between 2/8 and 3/8. And we can do then that's for the negative. If we wanted to reject this, one simple way would be to hope that this is negative, right? Because if you have a negative y value, you later on take the square root, it's impossible. So we would want to reject it. But here we have just shown that this, even though it's a minus sign, it is still a positive value, 0.3454. In between 2/8 and 3/8 is a positive value. So we cannot reject the y straight away. Likewise, for this other guy, positive plus positive, definitely still positive. So therefore, we cannot reject it straight away using the argument that y is negative. Is that clear so far?
Yeah.
So we cannot reject either one straight away. I mean, we cannot reject this one straight away because of a minus sign. Then now we have to figure out which is the correct one. Now, how do we do that? You need to realize that y is actually just equal to our cosine, our very, very dear and favorite x, but with a square. Y equals x squared. Our substitution, recall? We let y go to x squared.
Cosine square 18.
So cosine 18 degrees
square
squared.
18 equals to 0.9045.
Yeah, correct. It's around 0.9045, which means that this is the correct answer. The correct one to take. But imagine in a world before calculators, how would you do it? So this is when you need to draw the graph of cosine, draw the cosine graph. Okay, then that begs the question of how do you even know how to plot the cosine graph without a calculator? How do you know what are the exact points that the cosine graph will pass through? Let's pretend that we have the cosine graph and we don't think about how it came about, assuming that it is true. This will be cosine x graph, right? Can you agree? Do you agree?
Yes.
What happens if you take the cosine square? What happens if you take the cosine square?
If you take the cosine square,
So we're going to draw a new graph, y equals to cosine square x. What happens to negative values here?
positive.
Become positive. But let's focus on the positive parts here. Do you think when you square a number that's in between 0 and 1, it will become bigger or will it become smaller?
It become bigger.
Wrong.
Wait. Say again.
Yeah, try again. I draw it nicely first.
Wait, no, it will become smaller because like half, if you square half, it just becomes 1/4.
Which
So
is smaller. Very good.
Yeah.
Exactly. Cosine the y coordinates are, let's say, for example, here it's I don't know, this is what pi over 2, which is 1.57. This one is like, let's say 1. Then let's say in radians, then this will be cosine 1. Then now I'm asking if I want x equals to 1 and y equals to cosine 1, but you square it, would it be bigger than cosine 1 or smaller than cosine 1 or equal to cosine 1? You can, I'm using radians, sorry. I'm using radians. Maybe I should stick to degrees. Nah, I'll just use radians. Okay, cosine 1 rate in where 1 is radians is approximately 0.5403. And it's a decimal, right? Definitely, obviously, it is in between 0 and 1. So if you square it, does it become bigger or smaller? Smaller, right? So the relationship should actually be smaller, which means how would the graph look? If you have the same x coordinate 1, you will pass through cosine 1 square. Would it be above cosine 1 or below?
Below.
Below. So without knowing the value of cosine 1, we know it's a decimal. 0.5403 doesn't matter. We just need to know it's a decimal. And then when you square it, it must go below. So that means your graph actually, if it's exactly 1 square is still 1. So it will pass through the same point here. And then you can just draw the graph like this. When it's 0 square is also 1. Okay, then likewise, for the negative part, it will go below. So something like, wow, this graph is so bad looking. Can you try again? I want to make it look nicer. Let me try again. I want a nice cosine graph, so it's convincing. Down, down, up, up. And then the updated graph is, okay, this maybe I'll use a black color to label this point here. And then I want a red color. No, maybe I'll use blue color. Blue color for the cosine square graph. So it's slightly below. So the graph will look something like this. And then it goes like this. And then it goes like this. And then it goes like this. Do you see the blue graph?
Yeah.
Maybe my graph not so nice. Can I just show you the decimals? It looks nicer. Let me share screen now. Okay, this guy, is it showing? Okay, wait. No. Wrong. I need to do the following. Go here and share this fellow. Can you see the decimal screen?
Yeah.
Okay, so let's say we look at the cosine x graph. Let's say I restrict the what we call the domain to in between 0 and 2 pi radians. You can restrict the graph. Do you see that? It became shorter. Yeah, okay. No time to explain how to do it, but basically shortened version of the graph. Now we want the cosine square. Let's take a look at how it looks. Do you see what happens? So you see the blue graph is below the red one, but eventually it will meet at the same points here and here. And also it should go above. Sorry, my graph is wrong. Let me just make a quick edit on my version of the graph. So also you should realize that there is a smooth curve going on here. Here it looks like the right half of a set face, right? Can you see that? Over here at the beginning. At the beginning here. And then afterwards, from this point on, it looks like the left half of a happy face. Can you see that? Yeah. And then it goes on and on. It looks like a cosine graph again. Okay, so you can deduce that graph without knowing the numerical values, which means that, what am I trying to say with all this? What point? What is the point? Okay, let me just sketch the curve first. My graph is inaccurate. Let me try and sketch it more accurately. It looks like this, and then like this, and then it goes up again. Ayo, that's all right. It goes up like this, and then like this, and goes down, and then like this, and then it goes up, and then it goes like this. Okay, that is your cosine square graph. The main point here is that cosine of the cosine square value here, there are 1 comma cosine square of 1, it will be below cosine 1. And how much below?
Not that much.
Not that much, yeah. So only a little bit. Which means that this one would be closer to the correct answer. Is that convincing?
Yeah.
Hopefully. I don't know. This one is too far already. It's too far from the original. Too far from the original cosine value. Because after you square it, you get a value. After you square, you get a value. The original value, you cannot stray too far from it. This one stray too far already.
Okay.
Yeah, that's all I wanted to say. Okay, and then finally, once we are convinced that this is the root, then we can take the square root of this and we are able to get our cosine 18. So we just simply take the square root of that fellow over there, which is 5 over 8 plus square root 5 over 8. Simplify a bit. Let's see what we get. Is it clear so far what I'm doing here? Taking the square root of the y. X squared equals to y equals to this fellow. And then we want to solve for x, which is cosine 18 degrees. So we take square root. Is it okay so far? Can then now let's see what we can do. It's a fraction plus fraction. Denominator is the same. So we can just write as a single fraction. 5 plus root 5 square root. Then you just split on top and bottom. Square root on top, square root bottom. Is that okay so far? Can what is square root 8? It is how to simplify the set? Recall sets? You recall sets?
Times top bottom by square root 8.
No. Maybe you simplify this first. What you should realize is that it's actually 2 root 2.
Okay, times top and bottom by root.
Then you just times root 2. Don't need to work so hard. Square root 8, number very big. So, no. Let me shrink this down because I need more space. Maybe this one can be a bit bigger. And then finally, after you rationalize, you times the square root inside because both got square root, so they are in the same gang. Okay, same club. So they are able to join together. 5 plus root 5 can times 2. So you're left with square root, one huge square root, 2 times 5 plus root 5. All divided by 2 root 2 times root 2. Root 2 is 2. 2 times 2 is 4. Simplify a bit more, you're left with 2 times 5 is 10 plus 2 root 5, or whole thing square root, all divided by 4, which is our answer. Yay! Oh. You see that? Do you see that? Yeah, so much work just to get the exact value. Totally different from the 30, 40, 30, 60, 90, and 45, 45, 90 triangles, right? The exact values. Do you see that? Totally different approach. But if only there was such a way, where we could just get the exact value using a nice little drawing. Do you think there is such a way?
Yeah.
There probably is, right? So there is, but I will not talk about it. You can go and Google online. How do you find the cosine of 18 degrees geometrical approach? Okay. There are many other ways, actually. There are many other ways. here what I have decided to do is to find this special identity cosine phi x equals to this fella here. You could have also come up with any other ways. Maybe, I don't know, you could have taken like cosine 3x equals to 4 cos cube x minus, what was that fella? I can't remember the identity. Cosine triple angle. Triple angle identity. I think it was 4 cosine cube minus 3 cos x, right? This guy. You could have used this as well. Then all you need to do is to replace the 3x here with maybe like, I don't know, 18 degrees. Then this will be 6. This will be 6. Okay, actually that makes the problem a lot more difficult. The goal here is you want to make sure that one of these values are very easy to calculate. So what we have done is we have decided to pick x to be 18 such that 5 times 18 is 90 degrees. Cosine 90 degrees very easy to calculate. It's just a 0. Then subsequently the rest is just expression that can be solved for. Right, this is a power phi equation, but it can factor out the x. It becomes power 4 equation, but it's really just a quadratic equation in disguise. A quadratic equation in disguise. Okay. Yeah. Okay. Yeah, that's all. That's how you derive the value for cosine 18 degrees. Sorry, maybe I should make it at the bottom since this is the final conclusion. I'll just make it big. Super big. Yeah, our conclusion. Nice. All right. Right. Then what do you want next? That is question 25, which is super long-winded. Now there's question 26 and 27. Okay, there's no time already. So maybe I'll give you some hints on how to do it. I'll leave it as a homework, question 26 and 27. Okay?
Okay.
Hints. Let me list down some hints. So question 26. You got 10a plus sine a equal to p, 10a minus sine a equal to q. Prove that p squared minus q squared equal to 4 times square root pq. So this is actually, you just need to know that p squared minus q squared is nothing but p plus q, p minus q. Okay. Then when you try to sub in the p with whatever they gave you, 10a plus sine a, okay, you'll simplify a lot by using this identity. Okay. Yeah, then maybe you would have to meet halfway, because there is a 4 times square root pq, right? It's gonna be a little bit confusing. Usually the pq would be involving squares so that they will cancel off with the square root, right? Involve squares, power 2, so that they can cancel off, cancel with the square root. Okay, that's all the hints I'm giving you for question 26. For question 27, given that sine x equals to m plus n, cosine x equals m minus n, so show that m squared minus n squared equal to half sine 2x. So again, you need to realize that m squared minus n squared is nothing but m plus n multiplied by m minus n. Okay. Okay. Then what is m plus n? What is m minus n? Read the question and you will see. Then for m squared plus n squared, the part 2, you just need to know that there is a special identity over here. M plus n squared. Sorry, what do I mean by that? I mean open bracket m plus n close bracket square. Are they equal? Yes, they are equal. No, they are not equal.
No.
No, they are not equal. But if you expand this out, what you realize is that this is m squared plus n squared, but with an extra copy of 2mn. Now that you have done so many identities, hopefully you can immediately pick up that you just need to minus away a 2mn. Then they are equal now. Can you see that? Very good. So now that you know this special identity, it will be useful because you can now, let me think of it. Actually, is this useful? Hold on a second, let me think of it. Hold Hold on a second. Hold on a second. Right. Yes. 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 This is useful because you can always rewrite this as the following. Okay. Another special identity. This one is an algebraic identity. 2mn is actually the same as half times 2 times 2mn. Do you agree with that?
Okay.
Okay, which means that you can actually rewrite it as m plus n bracket square minus half times 2m times 2n. Do you agree so far?
Okay.
Then what we currently have is an expression for m plus n and an expression for m minus n. Right? If you're looking at the question, what's m plus n? What's m plus n? Question
M
27.
N.
M plus n is Are you looking at the question?
Yeah.
M plus n is question 27, part 1.
Sine X.
Sine x. Then m minus n is
Cosine X.
cosine x. That's given by them. If it's given, you must know this. Then after that, can you see how you can form a relationship for 2m in terms of sine x and cosine x? How about 2n? In terms of m plus n and m minus n.
2n in terms of
This guy, m plus n and m minus n. Can you see a pattern?
sine X plus, wait, no, sine X minus cosine X, or you mean? No, cosine X minus sine X. Wait, no. What am I saying? 2n. How you get 2n?
M minus n minus bracket m plus n. If you open up the bracket, you get minus m minus n.
Yeah, no,
The m cancel away. That's minus 2n. Almost there, just times negative 1. So this is actually minus 2n. So if you want 2n, it's actually just times negative 1 to this guy. So it's sine x minus cosine x.
minus cosine.
So this guy is sine x minus cosine x. How about 2m? I'll leave that as an exercise for you. Go and think about it. Then that's all for today.
Okay.
Okay. Now I gave you like more than this one 80% of the work already. 80% of the work already for part 2. Now you just do the rest. Or you can try on your own without looking at the hint. Okay, Ken?
Okay.
That's all. I'll assign some more homework from the Xingli textbook as well. I assume you have it.
Yeah, the big one, right?
Yeah, Xingli.
Yeah,
With a pen marker at the front.
yeah, I have it.
Have? Okay,
Yeah.
good. Then I'll send you